Yeah, fine. Hello, everyone. I'm Professor Pankaj Biswas. I am now in live session. If you have any queries, you can ask me your queries. First of all of you are very well familiar about this course, and I have seen a huge number of participants participated this time also in this course. This course is really a very interesting course for both beginner as well as who are interested to do higher study in future. For them also this course is really very important course. So all of you are very well familiar about the course name, that is Fundamental of Welding Science and Technology. So this is really a fundamental basic welding course. In this course, generally, the brief overview of this course, you can say, can be stated like this course will cover the industrial relevance of the welding process. It will also give the fundamental knowledge of various important welding processes, which includes the fundamental knowledge of the important welding processes, which includes most of the important fusion welding. So those welding processes generally in this course we focused, which are traditional and which have a wide application in the field of what is called industry as well as in research area also. In this course, we also cover the important and application of all these welding techniques. This course will highlight the issue which is related to safety precaution. And in this course also, the physics and principle of different welding process, especially fusion welding process related things I covered. In this course, generally also I covered the different types of defect which arise in welding process, that related things I covered, as well as in this course you will find the different types of techniques which we use to inspect the weld quality. That's both DT as well as NDT related welding, what it's called characterization techniques we stated in this course. So all of you are very well familiar that welding is such a process which is an unavoidable technology in most of the manufacturing sector, that you are very well familiar. So it is such a topics in which you will get the taste of most of the science and engineering courses. It's like, in welding college, in welding technology, knowledge of almost all science subjects like physics, chemistry, mathematics, engineering, and engineering subject like solid mechanics, thermal science, fluid mechanics, etc. are highly essential to understand the concepts of welding technology. So that's why what happens in this course, you can say, organize this course in such a way where you will get most of the fundamental knowledge of welding process, especially like here you will get the taste of physics of welding techniques. Here you will get the taste of what it's called, what are the different chemistry involved in welding process, that related things I have covered. So in this course, it's not only a theoretical course. In this course, you will get theoretical as well as what are the different types of mathematical background involved in this course. So after this course, you will really get the interest in future research, and you will get the taste of welding research oriented, what it's called, interest, that you can say. So it will generally encourage academic participants to increase the research interest in the field of welding also. Now, if you have any queries related to this course till now, whatever the portion we covered, you can ask me. In phone, actually, one of the students asked me, sir, actually, how we can categorize the welding process depending upon the position and all. on the position, welding is categorized into special different categories, you can say. Or we can have two different techniques, one is vertical up and another one is vertical. So this welding process generally, depending upon the position, positional welding technique, the easiest welding process you can call as downhand welding process, where generally the electrode position is along the direction of gravity, that means downhand type, and the plate is positioned in horizontal position. And the toughest welding techniques here you can say is the overhead welding process, where generally we did the welding, which is where the welding torch we position, which is where the droplet transfer generally taken place, which is against the, you can say, gravity. So that is the toughest welding process that you can say. So this welding process generally further we can group depending upon the what it's called type of welding process, like for bar welding process or groove welding process, as well as for fillet welding process. Once you open the WPS of a welding process involved in a manufacturing sector, WPS means welding process specification. So if you open a what it's called manufacturing details of welding process involved in a manufacturing process, if you open it, there you will find there we generally draw some name. Like there we draw some name like 1F, 1G, 1P, PA, sometimes PB. These types of different types of what is called nomenclature there also we use. So what are those meaning of 1G, 2G, 3G, 4G? So this also you need to know. Little bit I am explaining here. Depending upon the position of what it's called welding, you can write the nomenclature according to ASEM, AWS, that means American Welding Society. Similarly, IWS means International Organization for Standardization. Generally for ISO standard, then AWS, ASME standard. This positional welding also further group into, you can say, 6 different categories. And it is numbered from 1 to 6. Like 1G represent, you can say, downhand welding process, and G represent group welding. Group welding means butt types of welding. What I am telling you, have already very well familiar about groove, then bevel, then what is called V groove, J groove, U groove, that group related S preparation related things already I discussed at the beginning of this course itself. So you are very well familiar about all these things. So there actually I have not mentioned about this G or F related terminology there, but in a WPS, if these types of terminology are there, then you should know a little bit. I am explaining. 1G represent like flat welding. Similarly, 2G represent what is called horizontal welding. 3G represent vertical welding, which is grouped in nature. Group means butt welding, you can say. And 4G represent what it's called, you can say, overhead types of welding process. So these types of G represent groove. So now once we use it for fillet types of joint. Fillet types of joint means T-section joining purpose. Where the fillet welding, you know, fillet welding means the fillet joint is look like triangular in nature. Generally, to joint a T-section, we used to do fillet types of welding. So in case of flat welding, this flat, then what it's called horizontal, vertical, overhead. This welding process also further named as, you can say, 1F. 1F represent horizontal flat welding. 2F represent not horizontal. 1F represent what it's called flat flat welding or down and flat welding. 2F represent horizontal flat welding. 3F represent vertical flat welding. 4F represent overhead flat welding. Apart from these things, we can have pipe welding also. In case of pipe welding also, you can see there can be what it's called 1G, 2G, 3G, 4G, 5G, even 6G also are there. Actually, 5G represent pipe welding for, you can say, uphill types of pipe welding. Uphill means the pipe is positioned in some inclined position. What I'm telling, understand? And 6G pipe welding means it is, you can say, downhill types of what is called pipe welding. These are the different terminology also used depending upon the what is called position of welding as well as type of welding and its nomenclature. So in WPS, once you see these types of terminology, then you need to understand what does it means. So G represent depending upon the increase of number, you can say complexity or you can say toughness of the welding generally increase. Toughness of the welding process is increased, that you can say. That means its complexity increase. So that's why these are the very fundamental things you need to know. Okay, so so this I have not covered in this course, but as someone asked, that's why I am discussing here again. Okay. So sometimes actually this one thing you should keep it in mind. American Welding Society and what is called ASME. ASME means American Standard for Mechanical Engineering. So this AWS and ASME standard, it use generally 1G, 2G, 3G, 4G, 5G, 6G types of welding process terminology, but ISO standard generally use some different name that you can say. Like in ISO standard, you will see here 1G represent actually PA. Similarly, 2G represent PB. 3G, you can say 3G represent, sorry, 2 actually 1G and 1F represent PA, 2F represent PB, that you can say. So these types of PB, PC, PD, PE, PF, and PG, PAs, these types of different name generally it's give based on ISO standard. So this ISO standard generally will equivalent to what it's called, you can say, American Welding Society as well as what it's called ASME standard. Little bit I am writing this thing, then it will be very clear to you for your understanding later. Okay, that things I am going to write. Just I am opening the slide, then it will be very clear to you. So here I'm showing by writing what are the reference terminology used in AWS and what it's called ISO standard. Generally, AWS means American Welding Society and ASME standard. This standard generally use 1G, 2G, 3G, 4G, 5G, 6G. These types of terminology generally it's used for group welding. So what is group welding? Group welding actually is, you can say, part types of welding where we make a group and do the welding. So this is generally group welding, you can say. So in this group welding, depending upon its position, it can be 1G, 2G. Okay. Now, this is American Welding Society standard. So in ISO standard, I have already told you, ISO means International Organization for Standardization. In ISO standard generally, this 1G represent as PA, 2G represent PC, then 3G represent PF. This 3G represent PF for AFI types of welding process. 3G represent PAs for what is called downhill types of welding process also. So there is some nomenclature. Similarly, 4G represent PE, then 5G represent PAs, and 6J represent PJ. These are the different types of name depending upon ISO standard. This you should keep it in mind. Similarly, for so 1G equivalent to what is called ISO standard is represented as PA. Like this, you should keep it in mind. Similarly, for you can say 1F. 1F in ISO standard is represented by PA. 2F is ISO standard is represented by PB. Like these types of nomenclature are there. So to see what types of nomenclature generally used in WPS, WPS means welding process specification. So this is a, you can say in a drawing, generally these types of WPS terminology we use. So welding process specification, they are generally, instead of writing downhand, uphand, and these types of group welding and all the things, these types of short terms, 1G, 2G, these types of terminology generally used. So these are the different types of welding process. And what happens, depending upon the what is called experience on these types of different 1G, 2G welding process, you can say there are different types of means welder. You can say a standard is categorized. You can say welding certification generally programs are there. So if somebody have 1G, 2G, 3G, 4G types of experience, they have grouped into a particular welder group. If somebody have 5G yes, and some higher 4G types of what it's called experience, they have further have a little bit higher quality of you can say welder group. That types of generally depending upon experience of different types of welding process, the welder you can say is grouped into different standard, and their salary and other things also depends on these types of experience, that you can say. Okay, this you should keep it in mind. Any other queries? If you have any other queries, you can ask me. Anybody are in online? Nobody are there. Okay, fine. So one day, actually, one student was asking, sir, actually, can you please explain about what is called S preparation related things? So that related thing little bit today I am explaining. After that, actually, if you don't have any queries, then I will quit. So, yes, preparation of the welding process is a very important topic that you can say. So little bit I will explain generally about this S preparation. Generally, depending upon, you can say, what it's called thickness of the weld plate, the S preparation we can do in a what it's called welding process. Like some cases, it is not required to make any S preparation. Some cases, some what is called angle of the edge of the plate is required to make. Some cases, some curved shape is required to make, like what is called, you can say J types of groove or U types of groove. That types of groove generally required to make. So this groove generally required to make for different types of thickness of plate, depending upon what it's called type of joint as well as thickness of the plate itself. So why it is required? Generally, this is required because what happens if you will make this S preparation, then this S preparation can have different advantage. Like this, by this S preparation, you can control the welding distortion. By this S preparation, you control the weld material deposition. Yeah, by this S preparation itself, you can what is called reduce, or you can say control the amount of volume of molten material required in a joint. So you can control different types of what is called heating related effect, like you can reduce the heat affected zone, you can reduce the fusion zone and all that things. So that's why these types of S preparation is required for proper fusioning, for proper what is called getting of you can say well bit geometry. Generally, these types of S preparation are required. So what are the generally S preparation we used to get? Little bit I'll just discuss. Around 5 to 6 different types of what is called S preparation generally we use in case of welded joint, that you can say. So what are those S preparation? Little bit I am explaining. Okay. So I am showing those S preparation little bit here. Generally, the S preparation can be a square edge, a square types of S preparation it can be. A square S preparation means this is a plate. So here this plate is, this is the so this is one plate and this is another plate. These two plate we want to join together. Okay. Now, a square edge means here in this faying surface, the surface where generally the weld material is deposited, that is generally called faying surface. So here, if there is no, you can say only if it is what is called rectangular types of face is there, then what happens? These types of S preparation is generally called. That means there is no angle made. What I am telling, understand? This is generally called a square S preparation. So a square S preparation of a plate means here there is no what it's called angle we use. What I am telling, understand? Second categories of S preparation you can write as bevel S. Bevel S preparation means here we make some angle actually at the edge of the plate. So these types of, so you see this with horizon, with this vertical line, whatever the angle it's make, this is called bevel angle. Bevel angle. And the S preparation which is made in this plate, That is generally called vivelless preparation. This you should keep it in mind. Okay. So this what is called this vivelless preparation, generally it depends the thickness of the plate. It can be single vivel, it can be double types of vivel also. Double types of vivel means if the plate thickness is more, then what happens, instead of one side, you can make two side what is called vivel angle. What I am telling, understand? Two types vivel angle means this top side you can make a vivel angle, as well as in bottom side you can make a bevel angle. Now you already very well familiar what is the difference between bevel angle and groove angle. So the groove angle and bevel angle you are very well familiar. So I am not going in details about these things. Just I am discussing here about different types of S preparation. So this S preparation can be chamfer types of S preparation. Chamfer types of S preparation. Chamfer S preparation, it is generally have a it have a bevel as well as some root face. What I am telling, understand? So these types of S preparation, that means some portion, some thickness of the plate is beveling. After that, some portion remain unbeveled or S square types. So these types of S preparation is called what it's called chamfer types of S preparation. That means here some chamfering is made. What I'm telling, understand? So chamfer S preparation, you got the idea. It has a bevel as well as there is a root face. So no S preparation you can say. It is a combination of, you can say, a square and bevel types of S preparation. This is called chamfer S preparation. This S preparation can be what it's called J group types of S preparation also. It can be J group S preparation. J group S preparation, its shape of the S preparation is look like inverted types of J. These types of S preparation generally used for, generally thicker types of section. Because if you have a J types of S preparation, then what happens? You can reduce the volume of what is called material, volume of molten material you can reduce. Similarly, for double V types of S preparation also, it can reduce the what is called volume of molten material. Because this related things already I discussed in my course. You are very well familiar about all these things. But again, someone has asked, that's why I am little bit discussing about this thing. So what is the purpose of S preparation? You got the idea. The purpose of generally S preparation is to, you can say, reduce the molten material requirement, then reduce the distortion, then residual stresses, then you can say reduce the volume of molten material and all the things, reduce heat affected zone, and so it has different types of effect of all this S preparation. Okay, so what happens, depending upon the type and what is called range of thickness of the plate, you can use different types of S preparation. Okay. If you have any queries, you can ask me questions. If you don't have any queries, then no need to further discussion. Okay. Hello. Hello. Am I audible? Yes. Actually, you see, no further queries are there. Okay. Actually, nobody is in live also. Okay, so I think if nobody is there, so I think we can quit here, correct? Already half an hour is over. Okay, okay. Let's see another 1 minute, see if anybody will be there. 1 minute. And let's see. Actually, any other one is there. Another 1 minute. Okay, okay, fine. You can stop. No problem. This one you can do. Okay, fine. Thank you. I am leaving. Okay. Okay, I'm leaving, won't it? Okay, thank you.